Welcome to the presentation. This talk will review the top considerations for designing with SiTime's precision oscillators used in communication, enterprise, and 5G applications. We'll begin the presentation by reviewing SiTime's offering for precision oscillators. Then we'll review the three modes of operation that these oscillators support, and the various packages that are available. We'll also cover the integrated features that simplify their design and layout, as well as dual layout recommendations for embedding a TCXO inside of an OCXO footprint. We'll conclude with a summary of key manufacturing guidelines to ensure successful production. SiTime sells precision oscillators into a variety of navigation, radio, communication, and instrumentation markets. Our TCXO and OCXO devices provide frequency stabilities from 2.5 parts per million down to 5 parts per billion over temperature. These devices provide excellent dynamic performance in the presence of environmental stress due to changes in airflow, temperature, voltage, and shock or vibration. SiTime's precision oscillators support up to 3 modes of operation. The output frequency of the Elite family of TCXOs can be tuned using a voltage control, similar to traditional quartz TCXOs. But unlike quartz devices, the tuning linearity is excellent, with less than 1% deviation. In addition, both Elite and Emerald families support digital tuning of the output frequency using an I2C interface. This enables perfectly linear tuning and a much higher pole range of up to 3,200 parts per million. Digital control of the output frequency has many advantages compared to voltage control. For instance, the analog signal used to drive the voltage control pin is susceptible to noise coupling onto the trace over which the control signal is routed. This noise is a source of frequency deviations at the output, and also limits the minimum frequency resolution for pulling the output frequency. A digitally controlled oscillator does not suffer from such noise, and its frequency resolution can be made much finer. For example, the digital control in SiTime's devices can step the output frequency with a minimum resolution of 5 parts per trillion. This high resolution minimizes accumulated time error in synchronization applications. Another benefit is that voltage-controlled devices driven with a serial interface require a digital-to-analog converter. Digitally controlled devices integrate this converter, which results in a lower overall system cost. Finally, since the output frequency is pulled by a fractional feedback divider in the PLL, the tuning is perfectly linear, and the pull range can be programmed to be extremely wide, up to 3,200 parts per million. Such features improve dynamic performance in closed-loop operations. They also provide designers greater flexibility to optimize their systems. In addition to selecting an operation mode, designers will need to select a specific package. The native packages are the most cost-effective, which, for the Elite TCXO, is a 5 by 3.2 mm surface mount package, and for the Emerald OCXO, is a 9 by 7 mm package. Both families of products are also available in common industry standard packages to facilitate second sourcing. After selecting a package, designers will need to integrate it into their system. Designing with MEMS-based precision oscillators is much easier than with quartz devices. This is because SiTime's devices can be placed anywhere on a PCB, including next to fans that cycle on and off, or next to high-powered devices that radiate a lot of heat. There is no need to shield SiTime's precision oscillators from airflow or thermal gradients using a metal or plastic cover, as required for quartz devices. SiTime's precision oscillators also include multiple stages of voltage regulation to minimize the influence of power supply noise, which saves designers the expense of adding an external low dropout regulator. Lastly, a proper network of bypass capacitors should be used as documented in the datasheets. Designing with SiTime's precision oscillators is not only quick and easy, but extends the inherent benefits of MEMS over quartz to the design, including no activity dips or frequency jumps, plus a strong resistance to shock, vibration, and thermal dynamics. When laying out the selected package, some designs may benefit by supporting both Emerald OCXO and Elite TCXO devices. For example, if you are not sure what level of performance is needed, or if you want a single design to support multiple markets. In these cases, the dual layout shown here can be used to populate either device. Contact SiTime for more information. A dual layout can also facilitate co-designing with an Elite TCXO and an entry-level quartz OCXO. This can make sense in certain designs where an OCXO is needed for its lower frequency slope versus temperature performance compared to that of a quartz TCXO. In some cases, The frequency over temperature stability of an OCXO is simply a proxy for its frequency slope performance. Since the SiTime Elite TCXO frequency slope behavior is similar to that of an entry-level quartz OCXO, provisioning for both using a dual layout can benefit the design in two ways. First, the dual layout enables a lower-cost design when it is populated with the Elite TCXO, and second, the risk of sole sourcing the Elite TCXO is mitigated by the option of populating the socket with the OCXO, to maintain supply chain continuity. Using the Elite TCXO has the added benefits of improved performance under airflow, and cost savings associated with not requiring a cover for the Elite TCXO. We recommend the following key manufacturing guidelines for successful production. To prevent permanent or long-term damage, do not subject SiTime precision oscillators to ultrasonic or megasonic cleaning. Follow the recommended JDEC reflow profile provided in the datasheet. And for Elite TCXOs, it is important to use proper PCB solder and cleaning practices, which include thoroughly cleaning and drying the PCB soon after reflow, using water-soluble flux, and removing residual flux between the Elite TCXO and the PCB interface. Refer to the datasheet for more details. In summary, SiTime's precision oscillators feature several modes of operation, a wide variety of packages, and an unmatched ease of use. Dual layouts enable a single design to address multiple markets. They also enable Elite TCXOs to be a low-cost second source alternative to entry-level quartz OCXOs. Supporting frequency stabilities from 5 parts per billion to 2.5 parts per million, SiTime's precision oscillators are designed to optimize timing in a wide variety of communications, enterprise, and 5G applications. Please contact SiTime for more information, and thank you for your time and interest.